What is aerobic fitness? To fully understand and appreciate this concept, we need to take a little journey deep into the processes of the human body. As we discussed before, the human body maintains a remarkable balance. It's what is called homeostasis, a state of balance or equilibrium, even at rest or while you're asleep. This requires a constant supply of energy, and energy demands can change in an instant, like going from rest to a run. So it must be prepared for the continuum of human movement. The body achieves this constant supply of energy through two major energy production cycles. Anaerobic cycle provides a very quick source of energy and is used for short duration, high intensity movements like running, jumping, intense weightlifting, and sprinting. The process is called anaerobic because it does not need oxygen. But the consequence of not using oxygen to break down the glucose molecule, which is our primary energy source, is that the reaction is incomplete and leaves byproducts to be eliminated. The byproduct we are talking about is lactic acid. High-intensity activities cause a buildup of lactic acid in the muscles. Lactic acid fatigues the muscle and eventually causes it to fail. The feeling of the burn is an example of this. The body cannot maintain an all-out effort such as sprinting for more than about 1 minute without the muscles beginning to experience some buildup of lactic acid. Of course, training can push these limits, as you see with professional athletes, but even they have their limits. The aerobic energy production, on the other hand, is used for low-intensity, long-duration activities. Aerobic literally means with air or oxygen. Energy produced aerobically has no harmful byproducts to be eliminated, only water, heat, and carbon dioxide. Oxygen intake is the key. Since the heart, lungs, and blood vessels are responsible for delivering oxygen to working muscles, it is the exercises that force an increase in oxygen intake for a sustained period of time that are considered aerobic. Dr. Kenneth Cooper was one of the first to document the body's response to endurance exercises. He coined the term aerobics and further defines aerobic activities as those that are rhythmic, sustained, and employ the large muscle groups of the body. As you've already read in your materials, to receive the training effect from aerobic exercise, the training must be consistent, progressive, and specific. To achieve this, you must consider 3 training elements: frequency, intensity, and time or duration. Let's take a look at each one of those. Frequency of exercise is dependent upon several factors: fitness goals of the participant, the fitness level of the participant, and the intensity and duration of the exercise. The American College of Sports Medicine gives these guidelines. To improve fitness, you need to exercise 4 to 5 times per week, or 3 times for beginners. To maintain fitness, you need it 3 times per week, preferably evenly spaced so that the body can recover. Recent studies have proven that even moderate amounts of exercise can improve a person's overall health, and further, that overtraining results in very little extra aerobic gains, but with much greater risk of injury. Dr. Cooper recommends now that runners and joggers limit their mileage to 15 miles per week unless they're training specifically for a long-distance event. The risk of injury to joints and structures simply outweighs the benefits. The second consideration is your intensity level. Intensity is also determined by the fitness level of the participant and the duration of the exercise. As you have read, lower intensity levels should be used for beginning exercisers or those in very poor shape. The intensity level in an aerobics class should be progressive, similar to a bell curve. To elicit the best training response, the intensity should climb to 55 to 85% of a participant's maximum heart rate range and remain in steady state for 20 to 30 minutes. Let's take a look at what happens in the body as exercise intensity increases. When you go from a state of rest to movement, the body senses an imbalance in the system. All of a sudden, the muscles are in need of more energy, and the body responds by increasing the heart rate, the blood pressure, and the respiratory rate in order to meet the demands for oxygen. For the first few minutes of exercise, given that the intensity level is low to moderate, the body is using a combination of anaerobic and aerobic energy production. That's because it takes a while for the aerobic system to catch up to the demand. Progressing a class slowly through warm-up techniques and gradual intensity changes will help the body to meet the demands for oxygen more quickly and decrease the risk for abnormal heart rate responses or undue stress on the cardiovascular system. In other words, they'll be able to maintain that steady state longer and achieve more aerobic benefit. If a student becomes fatigued during the aerobic phase of the workout, they should be encouraged to keep moving at a lower level. Stopping suddenly can cause dizziness or lightheadedness from blood pooling in the extremities, mainly in the legs. The reason this happens is that while you are exercising, the contractions of the muscles help to squeeze blood back up to the heart. If you suddenly stop, the heart is left on its own to pump the same amount of blood and it can't keep up. The result is a buildup of blood in the legs and a lack of oxygen to the brain. Also, sudden changes in intensity can trigger abnormal heart rhythms in some individuals. Intensity level can be monitored in 3 ways: the heart rate, the tolerance, and the perceived exertion.